The second comparison is between aryl amines and ammonia. From pKb value, it is known that aryl amines are far less basic than that of ammonia, as ammonia is having pKb value of 4.75, whereas aryl amines are having the pKb value around 8.9 or more than 9 we have seen. So from the pKb values, it is known that aromatic amines are far less basic or weaker bases than ammonia, and also compared to the aliphatic amines. Compared to ammonia or compared to the aliphatic amine, aryl amines are very less basic in nature, and this is completely because of the presence of benzene ring. Okay, here I can take an example of aniline. If I take an example of aniline, it is having pKb value. Aniline is having pKb value 9.38, right? So it is weaker base. Why it is weaker base, that we'll see now. Due to the resonance. Due to the resonance in aniline, aniline may be regarded as the resonance hybrid of following structures. You already know that how to write the resonating structures for aniline. The lone pair of electron is present on nitrogen. So whenever the lone pair of electron is in conjugation with the multiple bond system or with the benzene system, they are undergoing delocalization, which is called as resonance. So here the lone pair of electron is delocalized over the benzene ring, and you get these resonating structures. And from these resonating structures, it is clear that the electrons are not located on nitrogen. They are involved in the continuous delocalization like this. And that makes aniline weaker base. So these are the resonating structures you can write for the aniline. Correct. So the negative charge is continuously delocalized over the benzene ring. That is nothing but the electrons are delocalized over the benzene ring in this manner. So the lone pair of electrons are not located on nitrogen. They are involved in the continuous delocalization. Because of this resonance, the electrons are less available for delocalization, or also you can tell that these electrons are less available for protonation to form the anilinium ion, because of which it is less basic in nature. And also you know that and also you can tell that when this aniline gets protonated, when this is undergoing protonation, there is a formation of anilinium ion. There is a formation of anilinium ion, which is a conjugated acid. So if this conjugated acid is stable, then this will be the stronger base. But this anilinium ion is not further stabilized by resonance. That is, only we can write two resonating structures for anilinium ion. They are H3 plus and this one. So these are only two resonating structures you can write for anilinium ion. So that's why it is less stable. You compare the resonating structures of aniline. There are 5 resonating structures. For anilinium ion, only 2 resonating structures. So if the resonating structures are more, then it is more stabilized. So aniline is more stable than that of anilinium ion. So this wants to be as aniline only. Don't want to get converted into anilinium ion, as aniline is more stable because of its so many resonating structures. And that's why you can tell that anilinium ion is less stable than that of aniline. So aniline is a weaker base. When electron donating groups are attached to the benzene ring, that is, if I take aniline here, when aniline is attached to the electron donating groups are releasing electrons towards the benzene ring. So as they are pushing electrons towards the benzene ring, the availability of electrons on nitrogen will be increased, because already these groups are giving electron to the benzene ring. So the benzene ring is not readily taking these electrons in the resonance. So for that reason, the availability of lone pair of electrons on nitrogen is increased comparatively, so that it stabilizes the formed conjugated acid. That is, these cations are stabilized because of these electron releasing groups. The electron releasing groups may be CH3 alkyl group, or methoxy group may be taken, or NH2. So such groups are electron donating groups. When they are attached to the aniline, they stabilize this conjugated acid and makes the substituted aniline as a stronger base compared to the aniline. Aniline with paratolidine, where we have CH3 group at para position, paratolidine or metatolidine. If I compare the basic strength of these two, the basic character of tolidine is more compared to the aniline. As CH3 is electron releasing in nature, electron donating in nature, it stabilizes the cation formed by the after the accepting the proton. Okay, so electron donating groups, when they are attached to the aniline, the basic character increases, the strength, the basic character increases. Whereas if electron withdrawing groups are present, what happens? If electron withdrawing group is present into the aniline, the electrons are dragged towards electron withdrawing group. It is taking the electrons towards itself. So what happens? These lone pair of electrons are involved in the resonance more easily. They are readily undergoing delocalization because of the presence of electron withdrawing groups, like No2 group. Electron withdrawing groups examples are NO2 or CN or any halogen if it is present. So they are all electron withdrawing in nature. So when such groups are attached to the aniline, the basic strength decreases, because electron withdrawing group means it is taking electrons towards itself. It is pulling electrons from the benzene ring towards itself. So these lone pair of electrons which are present on nitrogen are involved readily in the delocalization, because benzene ring becomes electron deficient. So it is eagerly taking the electrons from the nitrogen. So that's why when electron withdrawing groups are attached to the aniline, it is decreasing the basic strength, and also it destabilizes the positive charge or the cation formed after accepting the proton. Okay, and also you should remember, when the substitution is present at ortho position, they are usually weaker bases than aniline. So there is no effect of the groups, whether it may be electron donating group or electron withdrawing group. There is no change, or the basic character will be lesser than that of aniline, which is also called as ortho effect. So which is due to the steric effect or because of the electronic factors. There is no change in the basicity, or they are very less basic compared to the aniline. Ortho substituted anilines are weaker bases than that of aniline. So in total, to sum up, we can tell that electron donating groups increases the basic strength, whereas electron withdrawing group decreases the basic strength. And ortho substituted anilines are usually weaker bases than aniline, whether it may be electron withdrawing group or electron releasing group. Irrespective of the nature of the group, or at ortho position, no effect is observed. If they are at ortho and meta and para position, only then these effects are seen, and that too the effect is more pronounced if it is present at the para position. Let us solve one example here. See, arrange the following in decreasing order of their basic strength. So these are the given compounds. You observe that C6H5NH2, it is an C6H5 means it is an aromatic amine, right? Aryl amine. C2H5NH2, C2H5 twice NH, these are aliphatic amines or alkyl amines. And here we have ammonia. Correct. So we have to arrange them in the decreasing order. Decreasing order means first you have to write which is stronger base. Among these, which is stronger base? We have studied that alkyl amines are stronger bases than ammonia and also from aryl amines. So alkyl amines are stronger bases because of three factors we have to see. As they have not mentioned any medium, we have to consider this as a gaseous phase. If they are asking for aqueous phase, they will mention it. If they don't mention the medium, consider it is in the gaseous phase. So in gaseous phase, to compare the basic character of alkyl amine, which factor is considered? We have to think of only plus psi effect of alkyl group. So we have two alkyl amines here. One is ethylamine, other one is diethylamine. So in case of diethylamine, we have two alkyl groups. So plus psi effect is more compared to ethyl amine. So as plus psi effect is more in case of secondary, this is secondary amine, this is primary amine. So as we have two alkyl groups, the plus psi effect is shown by two alkyl groups. So it is more basic in nature. It is more stabilized. Cation formed by accepting a proton is more stabilized by two alkyl groups due to their plus psi effect. So secondary amine is stronger base, C2H5 twice NH. This is the stronger base. Then comes the primary amine. As it shows plus psi effect, one alkyl group is present. So this is stronger base. Then the next one will be either we have to take aryl amine or ammonia. And we have studied that aryl amines are less basic than that of ammonia, because in ammonia the lone pair of electrons are directly available for donation, whereas the lone pair of electrons in aryl amines are not available, because in aryl amines these electrons are involved in the delocalization, they are involved in the resonance. So this is less basic. So the next basic compound is ammonia. Then comes at the last C6H5NH2. So this is the decreasing order of the basic strength of these given compounds. Like this you have to solve the questions. This is very important for your all the examinations, and also they'll ask on the basic strength variation in gaseous phase, in the aqueous phase in the examination. They may ask even reasons also. So read that properly. For 2 marks they'll ask the question.